There are many techniques to assess rhythmic activity in EEG data. Here, we compute one of them, the power spectral density, or simply the spectrum, of our signal X using a well-established technique, the Fourier transform. Let's start by defining the spectrum. The spectrum of our data X is the magnitude squared of the Fourier transform of X. We'll see that the spectrum indicates the amplitude of rhythmic activity in our data X as a function of frequency. This definition of the spectrum is relatively straightforward. We can state it in a single sentence, as we wrote above. The second sentence above provides some intuition for the spectrum. The goal in computing the spectrum is to indicate the amplitude of rhythmic activity that contributes to X as a function of frequency. Although we can define the spectrum in a single sentence above and provide intuition for the spectrum using another sentence, there are many subtleties associated with computing and interpreting the spectrum. We'll explore some of them here. In doing so, we hope to build our intuition for spectral analysis and our ability to deal with different types of data we encounter in our research.